Good morning, afternoon, evening. This is a sad story about RPKI policy in the wilds and on the net, discovered by some of these folk due to messages from their NOCs. Not the way you want to find out about things. First, let's discuss the problem. Are you running route origin validation and dropping invalids? If so, you don't know it, but you are very likely to have some unhappy neighbors. They may not know they're unhappy yet. Once they hear of this presentation, they will know they're unhappy, and then everybody will be unhappy. Let's start with an oversimplified story of BGP, and this leaves out a massive amount. BGP is far more complex than this. There are people who are making their careers in BGP, so we don't want to see it all. What's essential here is we tend to differentiate between the control plane, where BGP, ISIS, and other routing protocols speak to each other, and the data plane, which is the decisions on forwarding using the FID, the Forward Information Database, which is populated by the best path from the routing decisions. So the routing information comes in from one side. The best path is chosen by policy. It goes to the output and sent to the peers. Now, the peers on the left and the right are really the same. This is just a display convenience. Okay? So it's the 1980s, and RAM and CPU are very small. Your watch has much more on it than those routers do. Cisco employee 4, the first engineer, Kurt Lohe, develops data structures and algorithms which get rid of the adrib in and out, which were large memory hogs, and he trades them for some very subtle and clever internal data structures and traversals. So let's pretend this is an adrib in merged into the mechanism, okay? So policy runs against the merged data and produces the best path. It produces an adrib out, which goes to the peers, and the same merging can be done for an adrib out. If policy changes, BGP wants those best paths to rerun policy. Oops, but those policy paths aren't there. What to do? Ankit Chen says, let's do something called route refresh, which is a message sent to my peers that says, please resend all the BGP paths you sent me, and I can rerun full policy against them. And this gets around the problem of not having an adrib in. And this is okay because policy changes very rarely, like once a month, once when the consultant drops in, who knows? So it looks like policy changes, the route refresh request is sent to the peers, and the peers send the data. But looking a little more subtly, if the adrib out is merged, the route refresh comes in from your peer who wants route refreshed. You have to traverse those internal data structures and produce the BGP paths again. This can be expensive for the sender. Okay? So, this works when policy changes very rarely. But RPKI data for route origin validation are new policy. They come in, they want to reevaluate best path and push it to the FID. The problem is they change very frequently, on the order of minutes. Okay, an hour at most, according to spec. And they must be done before the best path recalculation. So with merged adrib in, the RPKI data comes in. Oops, I need those paths. The route refresh is issued. The peers have to send all their paths all over again. And this is very frequent. Okay, if there are no data in adrib in, prefixes dropped by previous RPKI policy, i.e., they were judged invalid by route origin validation, they were dropped from the data structures. So they're no longer available. So for instance, if the RPKI data that came in made what was previously invalid valid, you don't have that path. So it has to issue a route refresh to all its peers. And as I said, RPKI data come in quite frequently. It's worse. If you had the adrib in, a new route origin authentication structure only affects a subtree of the paths, an operation traversal which is cheap and small. But if you issue a route refresh, you're getting a full table. And you must then reevaluate the whole tree, which is expensive. And it has the side effect that processing causes head-of-line blocking for all best path calculation. So new incremental normal updates coming in at the same time are sitting behind the head-of-line blocking, and convergence goes to hell. John Scudder points out a worse problem. In import policy, often changes only the relationship with a single peer, and then you only route refresh towards that single peer. If a row changes, you don't know what peers it affects. So you have to issue the route refresh towards all your peers. This is a little ugly. Here's the result. Here's AT&T telling CCOM, which is the cable provider going all the way from South Africa up the east coast of Africa through Europe, London, Marseille, etc., saying, you are driving us crazy, we're de-peering you, which is not really good for CCOM or the internet. It gets crazier. Think of an exchange point with all its members doing route origin validation and issuing route refresh to the route servers every few minutes. Or conversely, the IXP route servers getting lots of new rows and issuing route refresh to hundreds of peers every time they get new RPKI data. So this is a real mess. Are there solutions? The real solutions keep a full adrib in and adrib out. And some vendors do this by default. Many do not. Or it gets worse, but let's not get into vendor details. You probably can't do it on old hardware. On modern hardware, there's no excuse not to keep the adrib in and adrib out. You've got RAM. Shut up. We have a hack that we'd like to suggest. If you can't keep adrib in, when you drop an invalid, keep that path and only that path, but mark it in some way. Let's call that a minimal adrib drop. It's very small. It's only the dropped paths. Well, it's very small unless Vinny does another 7007 or Uninet Labs does another 128/9, as those generate a massive number of invalid origins, and therefore the address bin explodes. It's a hack you can do that at least lets you do origin validation. The third solution, don't run RPKI on any router which can't do the first two. Yep, turn off route origin validation, dropping invalids if you can't have an address bin and address out. This is not happiness. After these years of trying to promulgate this with the RPK origin validation now popular, and now we have to back off. How do you know if you have the problem? Well, different vendors will let you see whether you're issuing a route refresh and when, or they may not. Enka didn't give us a MIB, pardon me. Okay, so you can't use SNMP. Most vendors have CLI and Yang requests to get route refresh counts. Why did we have to find out from our NOCs? Why didn't we know this wasn't happening? Because we don't measure our networks well. You need to make friends with some routing researchers so you measure your network. You don't like these kinds of surprises. And that's it. Tony just asked a question online. Yeah, 2 is deficient, and we got an internet draft out on it. The only problem is if a flood of invalid comes, then that adrib suppressed will explode.
So the audience can hear the question. Your solution number 2 is sufficient, and there shouldn't be an increase in memory if the ROA changes as there are no new prefixes. The next question comes from Jonathan Stewart. How can I tell if my eBGP router is doing route refresh or keeping full ADJ ribs in?
Adrib in. I don't want to mention vendor names, but there's a significant vendor who by default does not keep adrib in or out. You would see soft refresh is their verb, I believe. That's lug memory. There's another significant vendor who does keep them because they were born when there was more RAM. You can tell by going to the docs or asking online, I guess. No love. Route refresh, as I said, there's no MIB for it, so look for a CLI query or a Yang query.
Okay. Any more questions from the audience or online? Going once? Twice? All right. Well, I'd like to thank you, Randy, for your presentation. And if we can get a round of applause for him, that'd be great.